Black hole. Many people say that black hole is the limit of human knowledge. True to its name, the black hole is always dark, strange, and terrifyingly mysterious. Today, the black hole is one of the key objects of human observation in outer space. But did you know that it wasn't until 2019 that people actually got the first image of this black lake? Before this photo was born, the black hole had always existed only in human theories or complex physical equations. But after the historic moment when the photo was published, everything became clear. The black hole really exists, and everything people have said about it up to now is true. For us, the black hole is an object that is both mysterious and scary, but contains the desire to understand the universe. So what do we know about it? How scary is it really? Can humans survive if faced with a black hole? Today, Primordial Universe will learn with you about the most powerful monster in the universe and how we survive when facing it. As usual, don't forget to leave a like and subscribe to the channel to support those who made this video. I hope you will have positive experiences with today's content. A black hole is a region of space-time where the gravitational field is so strong that nothing, including matter particles or electromagnetic radiation, can escape. For example, light cannot escape from it. General relativity predicts that a sufficiently large amount of matter within a small enough range will distort space, turning the area into a black hole. Surrounding the black hole is a surface called the event horizon, beyond which matter cannot escape. A black hole is called black because it absorbs all radiation and matter passing through the event horizon into the interior, like a perfect black body in thermodynamics. According to the formation method and properties of black holes, we can divide black holes into three types: stellar mass black holes, intermediate mass black holes, and supermassive black holes. Stellar mass black holes are black holes with a mass about 10 times the mass of the Sun, formed by the collapse of stars. This type of black hole is the most common, and so far many black holes of this type have been discovered. Intermediate mass black holes lie between stellar mass black holes and supermassive black holes, with masses ranging from a few thousand to 1 million solar masses. However, until now, there is still some controversy among scientists about how such black holes are formed. Supermassive black holes are the heaviest black holes in the universe, with masses ranging from millions to billions of times the mass of the Sun. Scientists believe that they may be formed through a special mechanism. Such as the merger of galaxies. That is, it can also be formed when two or more black holes absorb each other. Although by definition a black hole is a completely black or invisible area, its existence can be inferred through its interactions with the surrounding physical environment and light radiation. Matter falling into the black hole forms a convergence zone, where the matter collides and frictions with each other, becoming a plasma state, emitting intense radiation, causing the environment surrounding the black hole to become one of the brightest objects in the universe. If there is a star orbiting the black hole, its shape and orbital period allow astronomers to calculate the mass of the black hole and its distance. These data help them distinguish whether an ultra-dense object is a black hole or a neutron star. In this way, many black holes were discovered in binary star systems, and at the center of the galaxy, there is a giant black hole with a mass approximately 4.3 million times the mass of the Sun. One of the misconceptions when people think about black holes is that they are like extremely dense objects. As mentioned previously, it is true that black holes are made of extremely dense matter, but they themselves are nothing. Our Sun is about 1.5 million kilometers in diameter, but if we compress the Sun down to a smaller and smaller size until it turns into a sphere only about 6 kilometers in diameter, with a mass its own giant, then the Sun is forced to continue shrinking and then disappears. There is no surface, no matter who creates it. All that remains is empty space. If you get close to a black hole, you might not even realize that something terrible is approaching. Suppose you were going on a journey through space to enter and explore a black hole. How do you think the journey would go? Can you survive and get out of it? To explain this, we have to take a minute to understand what curved space-time in a black hole is. Since the 20th century, Einstein's equations have described how space and time react with matter and energy. Please search for the keyword Einstein field equations to learn more about those equations. If you throw something around the Earth, you will see it move in an arc. If you throw it fast enough, you can get it into Earth's orbit and it will follow a perfect curve. We have a few examples, like the International Space Station, ISS. For example, it was launched at a speed of more than 28,000 kilometers per hour on a curve where it was falling, or more precisely, a perfect curve around the orbit. Earth's orbit. Its engines were shut down, and it was actually falling around our planet. The orbits of satellites or the International Space Station illustrate a shape for curves in space. So if you're exploring space and don't realize you're encountering a black hole, you might get surprisingly close to it because no light escapes around the black hole. A black hole is like a lens, so the light around the black hole is distorted by the curvature of space. But instead of focusing or dispersing light, it bends the light infinitely. We will explain this more clearly when discussing black hole photos later. Going back to your journey, if you realize you are near a black hole, by then it will be too late. You will almost be held by it, and all attempts to struggle out will be ineffective. Even if you have some way to control the ship and escape, the first thing you will run into trouble with is the materials you are carrying. I will help you understand the reason by describing the difficulty when something wants to escape the Earth's gravitational pull. Do you know what speed is required for a spacecraft to launch into orbit? Only when achieving a flight speed of 7.9 kilometers per second will an artificial satellite or spacecraft not fall back to the ground. Ships on the moon need a speed of 11.2 kilometers per second, but to fly to other planets, the speed must be even greater. How do I reach that speed? Only boosters can handle this. To make an object move at a speed of 7.9 kilometers per second to escape the Earth's gravity requires using a large source of energy. For an object weighing 1 gram to escape the Earth, it will require an amount of energy equivalent to the electricity needed to light 1,540-watt light bulbs for 1 hour. On the other hand, rockets fly thanks to the gas spurting out behind them, creating a reaction force. The faster the gas is ejected, the faster the rocket flies. To achieve a very high flight speed, in addition to requiring a very high air injection speed, it is required to carry a lot of fuel. Assuming the gas injection speed is 4,000 meters per second, to achieve an escape speed of 11.2 kilometers per second, the rocket must contain some fuel several times heavier than its own weight. So imagine how terrible a gravitational force a black hole would create with a mass millions of times that of the Sun. Even if the ship can withstand that gravitational force, where are you going to get the huge amount of fuel to help it achieve the necessary escape speed? Once you enter the influence of a black hole, you will not be able to escape it. Right now, the answer to whether you can survive to escape a black hole. It was so obvious, there was no way at all. When approaching a black hole, not only is space warped, but so is time. The time between clock ticks, between breaths, and between thoughts seems to slow down compared to someone far away from the black hole. For yourself, the experience related to time is still completely normal because you are synchronized with the time reference frame around the black hole. As you get closer and closer to the infinitely curved space-time in the middle, someone outside will see that your clock has completely stopped. However, that is not all. After a while, if you can still survive, you will pass what is called the event horizon. This is the area where no matter, including light, can escape once it enters. Here, in the process of being sucked towards the event horizon, you will suffer a special effect called the spaghetti effect. Roughly translated as macaronization, this is one of the most famous effects caused by black holes. It's easy to imagine that anything that passes too close to a black hole will be stretched out like spaghetti strands. This effect is caused by the uneven distribution of gravitational force on the object. Imagine you are being sucked closer to a black hole with your feet facing forward. Gravity will pull harder on your feet than your head. It doesn't crush you, but stretches you out. Even worse, your limbs are no longer attached to the body's center of gravity, but will be wrapped in a different direction. As a result, the body parts will stretch out as if they were made of plastic. So you can imagine it's like Richard in the Fantastic Four, but on a much more terrifying level. It stretches and tears both you and your spaceship to the point that the molecule dissolves into nothingness, to the point of no longer being a normal form of matter. At this point, you are no longer anything. But let's continue to hypothesize that in some miraculous way, if you and your ship get through this area, what will await in the next places? Objects that go deeper into the black hole will face harsher conditions. The center of a black hole, also known as the singularity, is a place that cannot be explained by our current understanding of physics. This is a place with infinite density and gravity, but infinitely small volume. Here, the laws of classical physics will no longer hold, and the combination of quantum mechanics and general relativity becomes the only theory that explains the nature of black holes. With these extreme environments and incredible scenery, matter falling into black holes would no longer exist in our familiar universe. They can disappear completely or become part of a black hole. We don't have a definitive answer about the ultimate fate of matter, which adds to the mystery of black holes. Therefore, we will have many extremely interesting hypotheses. If you can reach this singularity, you must have seen the 2014 movie Black Hole of Death. Accordingly, after being pulled inside the black hole, the main character crosses the horizon of life, event, and drifted into five-dimensional space. Inside the five-dimensional space created by gravity, all light and sound signals cannot be transmitted outside. The idea of a five-dimensional space was raised by the film's scientific advisor, Kip Thorne, a famous theoretical physicist at the California Institute of Technology. This hypothesis is interesting because it describes the black hole as a photocopier of the universe. It is thought that black holes have another surface. Everything is not sucked into the depths of the black hole, but it falls to some surface. Look at counterfeit blank stamps, which have a virtual surface, and the surface of a black hole is the same surface. If this is the case, you may be at peace on a surface within another dimension. However, this surface has all the necessary conditions to depict a three-dimensional object, so you will be fooled into not realizing it is just a virtual image. This means that, who knows, right now we are already living inside a black hole, but things can go much further than your imagination. Not only the Earth, but the entire universe could also be in a black hole. This means that it is very possible that black holes will help us decode the origin of the universe. Surely many people have always wondered, if the Big Bang started everything, then what existed before the Big Bang? We know that the Big Bang happened about 13.7 billion years ago. Just 10 to 36 seconds after the Big Bang, space inflated like a balloon. Before the Big Bang, some researchers suggested that the universe existed as a single, dense, infinite point called a singularity. That singularity burst and has been expanding ever since. This is fundamentally contrary to the properties of black holes. A black hole is also a dense, infinite point in space-time. However, instead of spitting things out and expanding things, it sucks things in. However, if our universe is inside a black hole, as it continuously sucks in matter from the outside, it is clear that the interior is expanding more and more. Could the formation of a black hole mean the creation of a new universe within it? At the present time, there are opinions that it is impossible for black holes to reach such a huge size that they can contain the entire universe inside. However, the largest black hole we have ever discovered is TON 618. It has an incredibly huge size, with an event horizon more than 390 billion kilometers long, 43 times the diameter of our solar system. TA. This size is too small to fit in a galaxy, let alone the universe. So how could the entire universe fit inside a black hole? This universe is expanding so fast that we may never reach its edge. Due to the open curvature of space-time, our universe is most likely shaped like a donut. If you try to go off the edge of the universe, you will only be able to go around, and the final destination will be the original point where you started. Just like you can't reach the edge of the universe, you also can't reach the center of a black hole. So if our universe exists within a black hole, which exists within another universe, it means that reality consists of a set of universes overlapping each other, containing black holes carried in universes alone. If it's true that each black hole contains its own separate universe, then the true shape of the multiverse is something like a tree that keeps branching off into branches and then into other branches. The black hole universe theory can help us solve a number of other problems with physics. Specifically, it can help explain dark energy, which is driving the expansion of the universe. No one knows what it really is, or why the universe not only continues to expand, but is expanding at an increasingly rapid rate. So what would happen if that dark energy was caused by matter from outside our black hole universe being sucked into the black hole? Matter from the outside becomes energy inside and drives our expansion. This could also help explain the early and rapid expansion of the universe after the Big Bang.